Bismillahirrahmanirrahim. Assalamu alaikum. We shall study types of singularity, but as the Lorenz series play an important role to determine the types of singularities, so let us start from the Lorenz series. It is a series of the form summation n is from 1 to infinity a n z power n plus summation n is from 1 to infinity bn divided by z power n. We can see that this series has two parts. The first summation or the first part is called an analytic part, and you can see this is a part in which all z or z, we can say that z square, z cube, all the variables are only in the numerator. In other words, if there is no z in the denominator, that part of the Lorenz series is called an analytic part. And in the second part, you can see that all z, z square, z cube, and so on, they are in the denominator. So that is why this is called the principal part. In other words, that part of the Lorenz series in which all z's are in the denominator is called the principal part. And that principal part play a key role to obtain the types of singularities. Now let us start that what do we mean by singularity. So we can say that a point z is equal to a at which f of z is not analytic is called a singular point. In other words, that point at which the function is not differentiable is called a singular point. So if we are given a function f of z, and if we differentiate the function and then we put z is equal to a in f dash of z, and we get infinity or minus infinity, it will mean that f of z is not differentiable, and hence z is equal to a will be called a singular point of that function. Now, singularity has two types. The first one is called isolated singularity, and the second one is called non-isolated singularity. But we shall focus on the isolated singularity, which we can define that a point z is equal to a at which the function f of z is not analytic or is not differentiable, but it is analytic at each point in the neighborhood of z is equal to a. That point is called an isolated singular point. So we can say that if we are given a function f of z, if we differentiate the function and put z is equal to a in f dash of z, we will get infinity or minus infinity. So we will say that the function is not differentiable or the function is not analytic at z is equal to a. But if we take any point which is near to a, in other words, if we take a point a little less than a or a little greater than a, we will see that the function is differentiable or analytic at that point. So the function must be differentiable or analytic in the neighborhood of a, but it will not be differentiable at exactly at the point z is equal to a. And that type of singularity is called an isolated singularity. Now, isolated singularity has three types. The first one is called essential singularity. The second one is called pole. The third one is called a removable singularity. So now let us discuss the first type, which is called the essential singularity. So look at the definition. If if there are infinite number of terms in the principal part of the Lorenz series of a function f of z, then the singularity of that function is called an essential singularity. In other words, if we are given a function and if we express that function in the Lorenz series form and look at the principal part of the Lorenz series and there are infinite number of terms, then that type of singularity will be called an essential singularity. For example, I have to take a function. Let us take a function f of z is equal to e power 1 over z. Now you can see that at z is equal to 0, this function is not differentiable, or it is not analytic at z is equal to 0. So z is equal to 0 is a singular point of this function. But what type of singularity is that one? So let us determine the type of singularity. We have to expand this function in the Lorenz series. So e power 1 over z, if I expand this in the Lorenz series, I get 1 plus 1 over z plus 1 over 2 factorial z square and plus up to so on. So this is the Lorenz series of the function f of z is equal to e power 1 over z. Now this part in which all z's are in the denominator is called the principal part, and we can see that there are infinite number of terms in the principal part of this function. So that is why z is equal to 0 is an essential singular point of the function f of z. And now let us discuss the other type of singularity, which is called pole. So look at the definition. If there are finite number of terms in the principal part of the Lorenz series of a function, then the singularity of that function is called a pole. So let us explain this by an example. In this example, let us take a function. The function is f of z is equal to 1 over z plus 1 over z square plus 1 over z cube. Now you can see that this function is not differentiable at z is equal to 0. Or in other words, the function f of z is not analytic at z is equal to 0. So z is equal to 0 is a singular point of this function. But what type of singularity is this one? So look at the Lorenz series of this function. This is the principal part of the Lorenz series because all z's are in the denominator. And you can see there are finite number of terms. So that is why this is called, we can say that z is equal to 0 is a pole of this form. But this is called a pole of order 3. Now here you have to keep this in mind that even if we don't have 1 over z and if we don't have 1 over z square, if we have only 1 over z cube, still we will say that z is equal to 0 is a pole of order 3. So always take order from the power of z. For example, let us give another example. The other example I will say, let us f of z is equal to 1 over z minus 1. Now you can see that this is the Lorenz series and it has only one term in the principal part. So this type of singularity, or we can say that z is equal to 1, is a singular point of this function, and this is called a pole. And this is called a simple pole because its order is 1. But now, if I take z minus 1 whole square, we will say that z is equal to 1 is a pole of order 2, because we will look at this power. If there is 3, in other words, if I have a function f of z is equal to 1 over z minus 1 whole cube, we will say that z is equal to 1 is a pole of order 3, and so on. Now look at the third type of the singularity. The third type is called the removable singularity. So look at its definition. If there is no term in the principal part of the Lorenz series of a function f of z, then the singularity of that function is called a removable singularity. For example, let us explain this like this one. We have a function. The function is f of z is equal to sine z over z. And you can see that at z is equal to 0, this function is not differentiable, so it is a singular point of this function. Now let us expand this in the Lorenz series. So I can write f of z is equal to 1 over z, and let us write the Lorenz series of sine z, which is z minus z cube divided by 3 factorial plus z5 divided by 5 factorial and up to so on. Let us multiply 1 over z. So I can get 1. Here I can get z square divided by 3 factorial and plus up to so on. Now look at this function. There is no term in which z is in the denominator, or there is no term in the principal part of this function. So that is why z is equal to 0 is a removable singular point. For further discussion, please watch the previous lecture. That is all.